For today's quiz, I have a really powerful magnet. I also have a coil. And I also have an oscilloscope. And it's got a little calibration tab. It's built into the oscilloscope that allows you to see if your scope is working correctly. And it goes volt to volt, peak to peak, and it's also going to end up giving a frequency of 1 kilohertz. What we want to know is what happens if we take that AC supply, put it through our coil, and put it next to our magnet. Here's what your quiz looks like. I'll hold that up now. As always, mark your answer as completely as possible and list your level of confidence. Typical student responses will say, look, when I have a coil and I have a magnet and I'm oscillating the current, this thing will vibrate. And it should vibrate at 1,000 hertz, what the machine calibration tool is rated for. So most students are going to get that. Most of you will turn off at this point and say, okay, that was too easy, but stick around. There really is something worth watching here. All right, our students were correct. This is going to end up vibrating. So I'm going to take my magnet here. I'm going to take this yellow wire connected to that oscillating circuit, just AC. It's going to be a square wave, just in case you didn't know. And I'll connect this right to ground. Now it's going to end up essentially short-circuiting. It's going to pull this down, but that's okay. I want the maximum amplitude. When I put the coil onto the magnet, it's vibrating, and you can't see this. And a lot of students will say, well, that's not very exciting at all. Well, if I were to put a piece of aluminum foil on it and press down, hopefully you can hear that. And if you can't, I'll put another cone on it instead. I'll take just this cup and I'll push this on. And hopefully you can hear that. If not, let me get an even larger cone. And it ends up making sound. All right, so this is a very crude setup. Let me get something that has a little bit more oomph to it to show you this. All right, I've replaced the AC supply, which was never intended to end up pumping current through a coil, with something that is. And this is a function generator. You can see on the screen over there as I change its function. By the way, instead of a square wave, this one's going to be a sine wave. But notice I have my coil and it's connected here. As I take my magnet next to it, hopefully you'll be able to hear this. And if you can't, I'll do the same tricks that I did before. I'll put some aluminum on here. Even when it's off the magnet and just near it, you can still hear it. In fact, let's put the big cone on this. Or better yet, I'll use a small one. Essentially what we've just made is a speaker. When you have a coil and you put alternating current through it near a magnet and you let it vibrate, you make a speaker. It's that simple. All right, that's your quiz, but if you stick around, I'll show you some real speakers. I have lots of young people that are interested in speakers and their sound systems. And as we just found out, essentially all you need is a coil of wire and a magnet. Well, I took one apart, one of these speakers, and there it is. There's your coil of wire wrapped around either a little piece of thin metal or cardboard, and then you attach it to some kind of cone made out of paper or some kind of plastic material with a rubber buffer that will allow it to move. And that's essentially it. And of course, we need the magnet part. So the back part of a speaker is just a large magnet. Here's another one of these coils. This is, you got about, I don't know what, $1 worth of copper wire there. And then you simply place it in between the two pieces of metal here, and this will vibrate. And I'll show you that. All right, I have that old speaker hooked up to our signal generator. We turn it down, turn this on, and right away you can hear it's making noise. And in fact, here, I'll put it on a sine wave. Even without a cone, I could put a little piece of aluminum on here, see if it makes it any louder. And I'll turn it up, and you can see it works pretty well. Even without this piece of aluminum. Now, if I take it down in a frequency here, let me turn this down. Whoa. You can literally see it bouncing up and down if I had low frequency. Every time it oscillates back and forth, it'll cause that to vibrate, like a subwoofer or something like that. But I can go up to higher frequencies. And even without a cone, it makes a lot of noise. Now, the real question is, how does this magnet work? Where's the north? Where's the south? Let me go ahead and show you that. All right, to speed things up a little bit, I already drew a diagram up here, and I'll use my chalk to show the wires going around. Think of like shooting a bow and arrow. When the arrow's going away from you, you see the feathers. So we'll have X's right here. So think of this as like being a winding of wire going around, going in there, and you would see the point of the arrow coming towards you. And then it would go up here, and then the point would be down here. So I'm just going to loop wires around. And this is really going to end up being our magnet that we just showed you with the coil. So here's our coil. You can see the loops of wire going into the board, out of the board, into the board, out of the board. And then we have this center part, which would be right here, and then the outer part would be south and south. Let me go ahead and show you that. Put that on here. So I could say, well, that's north there, and this is a south, and that's a south. We can end up having field lines that are going to end up going straight up. So I could say, well, I've got field lines going from north to south like this, and then from north to south going down like this. I can put a north to south going up, going up. These are coming down, coming down. So the north points to the south. Use your right hand rule. I like to always have my fingers pointing from north to south. Now look, the X's indicate that our current from the wire would be going around the loop, going in on top and out on bottom. So I take my right hand, thumb goes into the board, I've got my fingers north to south. This is going to end up feeling a force out. Same thing on bottom. I take my fingers north to south, my thumb indicates the current is coming towards us. So they're also going to feel the same force. Maybe I could take a little piece of membrane right here like this and put these on here. And then I can end up putting our cone on here for our loudspeaker. So in this configuration, this would end up feeling a force out. And so this little coil in this magnet setup would jump out. And then with alternating current, it would pull in, back out, in, out. So all we've got is a coil in a magnet and a plastic or paper cone, and that is how you can make a speaker. Kind of neat. All right, that's your quiz. Thank you for watching another Idealized Science Institute video. We are a nonprofit organization. If you like what you've seen, be sure to like and subscribe, and if you want, leave a comment below. It's helpful to us. If you can financially support us, go to our website and hit the donate button. If you can't, simply by sharing these videos with other teachers and students in your life will be helpful. While at our website, you'll find that we have our Idealized Science Institute book that'll help you engage your students in dialogic discourse. There you'll also find we have a podcast where we break down educational research. We also have long-form lessons. If you're a teacher, you can watch these and go in the very next day and enact these. Along with this, we also have many other resources, including more quick quizzes. So thank you for watching, and we hope to see you in the next one.